Back. My name is Rupert Whitley. I work for DevOps Guys, and I'll be helping facilitate this for the rest of the day. Very lucky to have Stephen Murawski with us. Going to be talking about how he's implementing test or dev-driven tooling in an infrastructure environment. So take it away.
Oh, thank you. Yep. And so welcome. And just a quick little bit about who I am. I'm a developer advocate at Microsoft. Prior to that, I was a principal engineer at Chef and worked on ops at Stack Overflow and Windows admin, a couple other places other than that. I kind of found my way into working with configuration management and things while I was working at Stack Overflow, and that's where I got into desired state configuration. Spent a lot of time in this space at Chef, and today we're going to talk really about one of the core things, at least to me, in having successful configuration management, successful management of infrastructure as code, and that's the testing side of things. This is kind of a follow-on to a presentation last year that talked about the release pipeline model, which covered 4 kind of major areas where we wanted to get stuff into source control, we wanted to have a standardized build process, some tests, and then a flow to release that configuration out into production. And so just kind of a quick review of what the workflow would look like. You check something into source control. You have a CI server, which is basically an orchestration server that understands source control. Check out software. Who here is doing any kind of config management? Chef, desired state configuration, Puppet, Ansible, whatever. Okay. Who here is using some sort of CI pipeline with that infrastructure? All right, awesome, cool. So. So then that workflow is looking pretty familiar, right? You know, we get it out into production, we find out, oh, hey, there's either we get some feedback that that something's broken, or we have new software that needs to go out. For whatever reason, we need to change it. We update locally, we can do some tests and stuff, make sure things are good, get it into source control, and things go all again. Now, one of the things that kind of gets to be hard when we're first starting to look at what's all involved in a CI pipeline is what happens at each particular step. And I love this diagram, which somehow has disappeared from the web, so I've managed to keep a copy around. But this is actually kind of the shape of things that Chef Delivery would use. And Chef Delivery was a really opinionated CI pipeline. Not a huge fan of its implementation, but these concepts, I think, are actually very, very good and are very solid principles. And so what the workflow becomes is, just like Sam was talking about earlier, you have your pull request check-in that has some tests run against it. That gets in the master after it's approved. You run another series of tests against that. And then we test that one project kind of in isolation in an acceptance environment. The part that most talks about CI and CD miss is that last part there, is what happens after we've gotten through our pipeline. What happens when the thing that I built comes and collides with all the other things in our environment? Because the config management we write, the software we write, these things don't exist in isolation. They all have to come together and work together in a different environment. And that's what the union, rehearsal, and delivered. You could think of that as dev, QA, and production. You could think of whatever environment names kind of fit your world. But we have to carry some of that testing behaviors into those pipelines. Just something to keep in mind as we're looking, and this kind of is another look at, I have all of each one. My applications have their pipeline, my config management has its pipelines, but these things all need to come together in an environment. So that's one of the core reasons why I'm very, very strongly focused on testing our infrastructure, because the more automated tests that we have for this, the faster we can respond to problems in the rest of the stack. the quicker we can quash any problems that we have earlier in the process, shifting left, as we heard Sam talk about, and getting those test behaviors in earlier. So for the, kind of revisiting the release pipeline model idea, we're really going to focus on what happens kind of in this build test world, and specifically around several types of tests. We have syntax, lint, unit, and integration tests. And you might find other names for some of these things. Sometimes you'll see integration referred to as acceptance. We're going to talk about what each of these things is and look at kind of how those things happen. But at the heart of it, syntax tests are really just, is my thing valid? Is it valid PowerShell? Is it valid Ruby? Is it correct for, if I'm embedding strings and stuff, did I quote everything properly? Just making sure that the stuff's actually going to run properly when it gets somewhere. I can't tell you how many times I've saved a script, gone to run it somewhere, and I get, error on line whatever because I missed a quote somewhere or something like that. Right? Having a syntax check, some kind of validation before we go run something somewhere, is a huge win. And so we can encode that into our build pipelines to make sure that we have valid code, whether it's PowerShell, whether it's Ruby, whether it's command.exe. I doubt there's any batch syntax checkers, but hey, you could come up with something, I'm sure. But there are tools out there to validate what infrastructure look like, or what checks look like. A really quick and dirty one in PowerShell is read in all the code and try to cast it as a script block. And that will run the PowerShell parser and try to make sure that that's valid PowerShell syntax. I've used that kind of as a quick and dirty syntax check for PowerShell in build pipelines before, and it's cheap and easy to use. Then we have lint tests. Now, lint is more style checking and looking for kind of correctness. And so in the PowerShell realm, that's things like PS Script Analyzer. In the Ruby realm, that's things like Rubocop or Food Critic, if you're talking about specifically chef cookbooks. But we can include these things, and usually these tools have ways to opt into specific rule sets, extend them with your own rule sets, so that you can build the canonical what good code looks like for your organization, for your team, and have that enforced, some way that you can run locally and some way that you can run in your CI pipeline. And enforcing that in the CI pipeline enforces some nice code consistency for folks. And we spend a lot more time reading our code than we do writing it. Going back, looking through, troubleshooting a script, trying to figure out where you need to change something. When things are formatted consistently and there's consistent behavior across them, it makes it that much easier to come back and read what we've written before. Then we have unit tests. Now, in the sense in the PowerShell space, we have Pester. In the Ruby space, we have RSpec. And when we start talking about config management, when we start talking about unit tests, we have things like ChefSpec in the Windows or in the Chef world. But in the Windows side of things, we don't really have any tools yet around testing the MOF that gets generated. I know there's several efforts that have kind of been underway around that, but unit testing for config management really is about looking at the configuration that we're generating and making sure it has the resources with the parameters or with the properties that we expect it to have. We don't do a lot of that in the DSC world right now. I think we need to do more. However, the biggest bang for our buck when we talk about config management and infrastructure is the integration tests. Spending one of the reasons that we don't have a great unit test framework for testing against MOFs is it's some value, it's a good quick check, but it's not the biggest bang for your buck. The biggest bang for your buck is in your integration tests. And that's the thing that gives you the trust that your config management is going to do what you expect it to do. Because I don't know about y'all, but for me, having an agent running in the background on my servers that can change the state of them at any point in time is pretty freaking scary. I'm a control freak when it comes to what runs on my servers. I want to know how it's going to behave. I want to know that that in the middle of the night, it's not just going to change the state of things in an unexpected fashion. In order to get that degree of confidence in what's happening in either the DSC LCM or the Chef agent, I need to have some integration tests. I need to know, given a certain set of circumstances, how my config management's going to behave. And so that's what we're going to look at most heavily today. We've got some example code we're going to look at. We're going to look at a Chef cookbook, the shape of what's happening, and I'll call out some equivalents of where things happen with PowerShell DSC. But the shape of what happens, the types of tools and things are going to be the same whether you're doing Chef, whether you're doing Puppet, whether you're doing Ansible, whether you're doing DSC. It's all the same concepts, right? At the end of the day, we need to apply a configuration to a machine, a fresh machine, some base image that we know, something, get it to the state that we expect it to be, and then run some other tests against it with some other tool to prove that it got to where we need it to be. So what we're going to look at is, let's see, we're going to focus on a Chef recipe that uses DSC Resources. It's using the X Web administration module. And what we're going to do is we want to get IIS installed, make sure, no, I don't have to get my son ready for school right now. Let's see, is there a quiet mode, quiet hours? We'll see if that, so, yeah, right about now would be time I'd be getting my son up for school, so. That's why we had that little reminder there. So what we're going to do is we're going to install IIS, we're going to, or make sure it's installed, and we're going to use the Windows feature DSC resource. We're going to make sure the W3 service is enabled and started, that the default website shut down because I'm going to stand some other stuff up. And then, based on configuration data, now in the Chef realm that's attributes, but in DSC parlance, that would be configuration data. I want to stand up some websites. And these websites are going to be driven based on the attributes I've set. And I've got, I'm going to have a site clowns, sites about bears, and one's going to be on 80, one's going to be on 81. Oh, wrong recipe. We'll close that out. And we went. All right. So we've got some DSC resources in here, X website, X web binding, all that kind of fun stuff. And a little PowerShell script to make sure that the firewall's open. And I could have found another DSC resource for that, but I just decided to do the PowerShell script. Now, the tool that we're going to use to test that this stuff actually worked is a tool called Test Kitchen. There are other test tools out there that can do similar stuff. If you're in the DSC realm, Lability is a good option. There's a couple other tools. I think Beaker is one that's out there. Test Kitchen's the one I have the most familiarity with. And Test Kitchen allows you to wire up a way to create a machine. We're going to use Azure in this case. Could use Hyper-V or Vagrant or AWS, whatever, wherever you can spin up machines. Test Kitchen's probably got a plugin to make that happen. We're going to use a provisioner, which is a way that we're going to apply our configuration. Since we're doing chef recipe here, that's what we're going to use to apply the configuration. There's provisioners for desired state configuration. There's Ansible, Puppet, all sorts of things. Actually, there's a whole. Let's just do. Test Kitchen. There is an ecosystem doc here that actually shows a good number of the plugins that are all available. So there's some VMware integration. There's Salt, Docker, also Terraform, all sorts of fun stuff. So regardless of what you use for creating machines or applying configurations to them, Test Kitchen probably has something that can work for you. Now, we're going to use Azure. We're going to spin up a 2016, Server 2016 node to apply our configuration. And we're going to tell it what recipe to apply. We don't have a ton of options to apply to this. This is a pretty vanilla example. But we've also told it we're going to use Pester to do our tests. So what we talked about, I said we're going to use Chef to do the provisioning. We are going to do, we're going to use Pester to run our tests. So I have, for this particular site, I've got some tests already set up, and we're going to add some more. So the Clowns website is going to be available on port 80, according to my tests. And it's going to have certain content available on the page that says that we love clowns. Port 81 is going to be hosting a site that says we love bears. And let's see here. Now I've run this base one already just for time purposes. And so we can go take a look at, here's what's running on port 80. Now, and let's look at port 81. Now you can tell my web design skills are top notch. I am an expert in crafting HTML. Yeah. No, my skills are much stronger in writing configuration management than it is in HTML. So we will deal with some plain HTML blocks here. But now I know this page is serving this stuff up, and I can validate that from the command line with Test Kitchen. So like I said, I've already done this locally. We're going to also do this through a CI pipeline. But just to see the state of the machine that's in. So Test Kitchen has a command line, kitchen, and I've asked it to let me know about any instances I have that start with DSC resource. So it tells me that we're going to spin them up in Azure, using Chef 0, Pester to verify it, WinRM to talk to the node, and it says the last thing I did was verified it, so I made sure that it worked. So just to show you what the verify looks like, let's just do. So now what this is going to do is it's going to reach out over WinRM and run that PowerShell, that Pester test against the node that I've run my config management on. We're going to change the configuration in a little bit, and we'll update the tests just to see how we can write our test, have a test fail, and then go change the config management to make it succeed. So right now, everything's happy. It thinks that the clown's website's on the right port, it has the right content, Bear's website's on the right port, has the right content. Now, we're at WinOps, and so why don't we add another website to this collection of things? Let's find my attributes file. We'll hide that. So we're going to add one more site. Now, this is Ruby. Ruby hashes look very much like PowerShell hashes, so you should probably be able to follow along here. But we're going to create one for WinOps. So we can say, we love WinOps. And we'll put that on port 82. Now, I've changed the metadata. I haven't changed the structure of my sites. Actually, before we do this, because doing this would be backwards, we need to write a test first. So I want to have a site about admins. I'm going to use the well-known technique of copy-paste, or WinOps. And it's going to run on port 82. And it's going to have the right content. We love WinOps. Now, any ideas what's going to happen when I run my tests? I heard pass and fail. Okay, pass. All right, cool. You guys are following along well at home here. Let's just to make sure. I did save it. Yes. All right. So we're going to fire up Test Kitchen again here. It's going to go out over WinRM, reach out, run that set of pester tests. And what's nice here is I'm working on a machine in Azure, but I'm doing all the editing locally on my machine. And so I get this, it's a slightly faster. It's still slow because I have to reach out over the network. But I'm getting relatively fast feedback on my changes. And so now we got our errors. That is good. Except responds in port 81. We did not change the wording there. All right. So, yeah, copy paste, sometimes not so slick. All right. So we are going to now run the config management and see if everything worked just fine. So we're going to tell it to converge. And what this is going to do is it's going to go, again, reach out over WinRM to that node sitting in Azure and tell it, hey, run chef with this new cookbook. Oh, yes, I did not. Good call. So let's stop that. All right. And we need the attributes. We need to uncomment that. Now let's try that. Good call. I tried doing things out of order before, and then you start missing stuff. But that's why we have tests too, right? It would have ran through, my test would have failed, and I would have known something was off. But this just saves us a little bit of time. So the client run's probably going to take just a minute here. Almost everything should be in the right state, except for we'll need a new site for We Love WinOps. And while this is running, I'm going to take us over and we're going to take a quick look at the CI build for this project. Now, we just looked with Sam at VSTS. This is in VSTS. You can build this workflow, though, in any CI tool. This could be Jenkins. This could be Team City, whatever. I have Azure Credit, and small projects are free in VSTS. Projects for under five or less users, private projects are free in VSTS, which is kind of nice. And you can also wire up builds to projects in GitHub, which is nice. If you keep, as long as you have the 5 users, it's free, which is really handy. But we have these phases that I talked about. We have the lint and the syntax checks. And in the context of Chef, there's a command line, delivery local lint, delivery local syntax, delivery local unit, to do those things. When we get down to the integration test, I'm doing integration tests at a different time than you'd see in traditional application development. Traditional application development, you'd see integration tests after you have a successful build. In the config management context, our integration tests are really more are really there to validate that the config management we built works, and so we want to do that before we create that artifact, that final release of the cookbook, that final release of the PowerShell module. We want to do our integration tests a little bit earlier in the cycle, and so this is something that we're using the same term as a lot of application developers in this context, but it's at a slightly different time in its point of life. So what we're going to do in the CI pipeline is kitchen test, which is going to run through all of the phases of kitchen, and it's going to spin up nodes. It's going to run the configuration management. It's going to run the tests against it. And then we're giving it a flag to destroy because this is unattended. Normally kitchen, if a node fails its test, it'll leave it around for you to go inspect and play around with and figure out what went wrong. We're going to tell it to destroy always, and we're going to give it -C to tell it to do this thing concurrently because we're using Azure, and we have, Azure's got a lot more resources than I have on my local machine. We can spin a bunch of stuff up all at once. So that's what's going to happen in the CI pipeline side of things. It's the same behavior, though, that I'm using in my local dev experience. Now, this is finished running. We've finished running our Converge. And it said it updated 6 out of 85 resources. Let's see if our site is there. Oh, wrong browser. All right. So we'll go back through the list. We have port 80. We love clowns. That's there. Bears is there. How about our WinOps? No, Bears. Oh, there we go. Just took a second. A little bit of latency. All right. So we love WinOps, and let's make sure our tests pass. Now we don't need to we want to get away from the point where we manually go see if things succeeded. It's just nice to have a visual in a demonstration, but when I'm actually doing config management development, I rely much more heavily on my tests than I do on visual inspection. Now, once we get through this verify stage, fingers crossed. Now, I'm crossing my fingers here because I'm hoping my tests pass. This is all happening locally. And it's so that I don't have to push and pray, where I'd push my code to our CI server and just hope it passes. I want to know that the stuff I've just written is going to pass when it gets to our CI server. Now, you might think then, oh, well, then why do we have to duplicate this work on the CI server? Well, we want to catch all those scenarios where maybe somebody didn't run it locally or only ran a subset of tests. We want to make sure all of the tests that are valid and important for us, we run through our CI system. So, 6 passed, woohoo! Things are looking good. So now, let's see, we've modified a couple of things. We've modified our tests. We have modified our attributes. So let's add that stuff in. Give it a commit message. I GPG sign my commits. It's been something I've done for a long time. That's what that little thing is there. And now we're going to do what I tell everybody never to do and push right to master. But that's going to kick off, that's going to trigger our build. And we're going to see what happens now on the CI side of things. So it's already in progress. And we've already gone through the lint and syntax phase. Those checks have already run. Now it's going to run unit tests. There's not going to be much for that here. And then we're going to get on to the integration test. It's going to run the same behavior there. Now we're getting towards the last third of our time here. So I'd like to open it up for questions. We do have a microphone, so if you have a question, if you wouldn't mind waiting for our kind host to make his way towards you.
Yeah. It was about, you know, your metadata or your attributes for your cookbook.
Mm-hmm.
Would you recommend importing those attributes into the pester tests so you're referencing the same data? Or would you statically write the values like port, IP address in the test? Do you have a preference, or is there, you know?
No, that's always that's often a debated question, right? And for this type of scenario, yeah, it would definitely make things a little bit smoother and clean up a little code reuse, a little copy-paste code. There are some other scenarios where you're going to treat the attributes that are set in the cookbook kind of as default values that are expected, right? So it really depends on the use case for the cookbook. If this is a library cookbook or a library module, I'm going to share out with the world that has some common defaults. I'm going to write my tests hard-coded against those defaults. And then other people can write tests and pass in other attributes. Test Kitchen allows you to override that data in different ways so that you can make it look more like different environments. So but then you're going to want to write your tests to understand that data that you're passing in. So I could write it to read that particular node or that particular defaults file, but only if I know that's the only source of variability that's coming in. Does that help a little? Clear as mud? All right, I think we had a couple here. And just that gentleman stand up.
A lot of the infra testing tooling I see is targeted at testing nodes like IaaS VMs. What's the tooling around testing PaaS components?
So from the config management side of things, most of what we're targeting is going to be VMs. Testing against PaaS components, Inspec has announced some stuff about Inspec is a testing tool from Chef. They've got some, Russell might know a little bit more about this, but around asserting some things about the state of your ARM resources, which may get you part of the way there. The other thing is we're going to test behaviors. right? If you look at the tests that I was writing really briefly, I'm getting certain content back. I'm going to test the APIs that are being exposed. I'm going to look for errors being thrown in these tests. So I'm looking for the service behaviors, and that same pattern would work in testing against. And InSpec has resources for this. Pester, PowerShell, we can craft URLs and send stuff. Almost all your testing frameworks are going to have some capability for like reaching out to APIs, and that's going to be more the route than trying to test inside the PAS resource. Other questions? Wait, Susan. Yeah.
You're testing localhost there for integration, but not actually whether the website's being served externally. Should that not be
Yep, so that's an implementation detail of the Pester test runner. It's running locally on that system. And yes, now the InSpec test runner kicks off from your local machine. It's an implementation detail of the test of the driver or of the plugin for the test framework in Test Kitchen, and it totally could be if there was enough demand for that. I'd be happy to implement that, where you could choose to run locally or remotely. I'm the maintainer for a couple of those plugins. Other questions? Who is doing some sort of oh yeah.
Just trying to understand fully on this one. Is there actually a need for a chef server as part of this configuration? No. Okay. Thanks.
No. So there is not a need for a chef server as part of this testing. It's using a mode of chef where it spins up a local in-memory lightweight version of the chef server to talk to. It's called local mode, and the DSC implementation of Test Kitchen doesn't require a pull server. It just uses the start DSC configuration and points it right at the node. The exact same patterns that we just went through and worked with are completely available, whether it's Chef, whether it's DSC, whether it's Puppet, whether the patterns and the shape of this is pretty universal. The exact look of the config management changes a little bit, but it's all kind of plug and play. Is anybody doing any integration testing of their config management? All right. Anybody willing to share a little bit of their experience? What's been hard? What's been easy? All right. We got a mic coming back for you.
Hey, great talk. So just from our point of view, one of the things that we found tricky about integration testing on Windows was handling reboots. So we found that there are some magic numbers to do with weights, like connection weights and chef retry weights. So if you've got stuff that requires reboots and stuff, if you're running into problems, it's definitely worth like knowing what those values are. We're putting blog posts out about what we found those numbers to be. It might benefit some of you that are doing reboots on Windows.
That's awesome. Yeah, one of the challenges is very often in Windows we have to reboot after installing a feature or installing some software. Test Kitchen does have support both in the Chef provisioner and the DSC provisioner, and it's just kind of baked into Test Kitchen, and others can take advantage to support controlled reboots. And but one of the challenges, as noted, was the timing on retries. So depending on where you're spinning up those machines, what your latency is to them, how many resources those machines have. If I'm running something locally on Hyper-V that I've given 4 cores and 8 gig of memory to, it's going to behave differently than an A1 in Azure, right? And so knowing how quickly those nodes are going to process. If I install SQL Server, there's going to be a little bit of a lag time from when I do the reboot, from when things go down to when they come up, and Windows is configuring itself, and so you need to be able to play a little bit with some of those reconnection times, because Sometimes services aren't ready to hear you yet, or we haven't completed the reboot yet. And so that does get a little tricky. Good point. Anyone else? Something that they found challenging or really rewarding with infrastructure testing? All right, we're getting you a workout.
Yeah, making me work.
Back of the room to the front of the room, back of the room to the front of the room.
We found we could use the integration tests that we used as first-line support pester tests.
Mm-hmm.
So when something goes wrong, run the test, you see how the environment is.
Awesome.
But my question was,
Mm-hmm.
the most difficult thing is, how do you ensure that your tests are going to fail when you expect them to?
Expecting your tests to fail when you expect them to is a really tough thing when you write your test after. One of the benefits of test-driven methodology is that we write our test first, and we don't start writing code till we have a failing test. So we know our test fails, and we write just enough config management to make the thing pass. And that's what gives us the confidence that, okay, our test will fail when we've got an absence of the good scenario. Does that help a little? Yeah. Yes?
One of the things we found earlier, sorry, hello? Okay, how to, what is the best practice to store things like SSH keys, SSL certificates, passwords, sensible vaults. One of the practices that we did earlier was to store them in probably, GitLab or GitHub, but that's not the best practice, I think. Is there anything that you can help us to?
Yep. So for the purpose of tests, or or just in general with config management? Yeah, storing secrets is a challenge. There's a couple of approaches that I've seen people take. Number one is encrypt them encrypt them outside of encrypt them and store them in source control along with, like, so your SSH key or your SSL cert. Encrypt them with something else and stick that blob into source. The other is to store them outside of source in something like Key Vault, or if you're running a Chef server, you could use like encrypted data bags or Chef Vault, and you're storing them outside of and referencing them from your config management. Both approaches have their pluses and minuses. There are a couple of projects in the DSC area and in the Puppet area around getting things encrypted and keeping them alongside in source control. Usually in the Chef community, you see people want to keep those secrets outside of that and have them in some other store, whether that's an encrypted data bag or Chef Vault, or something like Key Vault, or some other third-party secret store. All right. With that, I will give you guys a couple minutes to get started for lunch, and I will be around the rest of the afternoon, and I'm happy to have any hallway conversations or things there. Thank you all.